Hello students, we are studying about optical properties of radio waves. So we have seen four optical properties are there. One is refraction, reflection, diffraction and interference. Last class we have studied about refraction. In today's class we will see about reflection and the other two properties. See, as already you have completed in your physics course about those things in detail, so here only we will see the basic concepts. Okay, so first let's see about the reflection. Okay, so reflection is what? Whenever a electromagnetic wave is incident upon upon the boundary of the two medium, or you can say the two surface, and if the ray is reflecting back towards the same medium, then you can say the reflection occurs, or you can say the electromagnetic wave reflection occurs when an incident wave, this one is what, your incident wave, strikes at a boundary of two media. This is medium 1 or media 1 and media 2. Okay, and that line represents what? The boundary of these two media. Some or all of the incident power does not enter the second material, that is they are reflected. Okay, sometimes it also happens that some of the rays may passes to the medium 2. Okay, but in reflection what happens? All the incident rays or waves, okay, they'll reflected back towards the what? Same medium. Okay, so here what happens? As both the incident ray and reflected ray are present in the same medium. Okay, so here the velocity of the incident ray and the velocity of the reflected ray are same, so that's why Vi equal to Vr. Okay, and second thing is that you know that the from refraction about the angle of incidence. Okay, same thing is here. This theta I represents what? The angle of incidence, and theta r, this is what? Your angle of reflection. Okay, that is the angle between what? Reflected ray and the normal, and angle of incidence what? The angle between normal and the incident ray, and this theta I and theta r values are same. Okay, theta I equal to theta r. Okay, that are the basic properties of reflection. Already you know that thing. Next we will see about the reflection coefficient. Okay, reflection coefficient is generally denoted by the symbol gamma. Okay, that can be found, that can be calculated by taking the ratio of the reflection power, or the you can say the reflected power to the incident power, or you can say the ratio of the intensity of the reflected ray to the intensity of the incident ray. Okay, so mathematically it is written as gamma equal to PR by PI. Okay, gamma is what? Reflection coefficient, and that is unitless, and PR is what? Your the power reflected or reflected power, and its unit is watt. Okay, and PI is the incident power and its unit is watt. Okay. Next, that reflection coefficient value is 1. Okay, for perfect conductors. Okay, that means all the incident power is reflected, but for imperfect conductors the reflection coefficient value is not equal to 1. Okay, it varies, and that value depends upon these three parameters, that is angle of incidence, the electric field orientation, and the dielectric constant of the two materials. Okay, next thing is that I have already told you, in case of reflection it may be possible that some of the incident wave may pass to the medium 2. Okay, and if it is the case, then those those rays are absorbed and that will be converted to the heat energy. Okay, next we will see one classification of the reflection. Reflection can be classified into two types. One is specular reflection, second one is what? Diffuse reflection. Okay, and specular reflection is just like mirror like reflection, and if your surface is irregular surface, then that type of reflection is called as what? Specular reflection. And if your reflection is taking place through a smooth surface or regular surface, then that type of reflection is called as what? Your diffuse reflection. Okay, next we will go for the another optical properties, that is called what? Your diffraction. Okay, diffraction is what? This is an optical phenomenon which describes the bending, or sometimes that is called what? Scattering. Scattering of the light waves around the edge or corner of an obstacle. So see here, this one is what? One obstacle. Okay, this is obstacle, and this points represents the light source from where the light is emitting. And as this one is obstacle, so light ray cannot pass through this obstacle, and this line represents a screen. Okay, so as you know that light wave travels in a straight line, so you can think that or imagine that if the light ray is coming from light source in this direction, then it will fall in the screen that point. Okay, in this way. Okay, and in the bottom part of the obstacle also you can see the spot of the light here. And as the obstacle is present here, so behind this a shadow or darkness should be there, but generally the case is not like that. Practically it has been seen that in the shadow part also some dark as well as bright spots are there. Okay, and that is just due to your diffraction property of light, because at the corner and this is also called the edge of the obstacle, some of the light rays are bending. Okay, and due to that bending or diffraction properties, you can see some light spots or some dark and bright spots alternatively in the shadow region. Okay, another case you can take, suppose here one slit is there. Okay, between two obstacles, and here also you can see that no light should be observed in that part. Okay, in this part also, but due to diffraction, some of the light ray is scattering or bending near the edge or corner part. Okay, that's why some dark and bright spots are observed there. Okay, so diffraction is the phenomenon that light or radio that allows the light or radio waves to propagate around the corners. Okay, you can take one real life example. Whenever you will open a door to a dark room, then light rays diffract around the edge of the door, and it will illuminate the area behind the door. Okay, you can practically experiment this thing. Whenever you will open a door, okay, and the light is off inside that room, then while you will open that door, it will illuminate the area behind that door. Okay, but that should show the darkness, but it will illuminate behind that door. Okay, next we will see one principle that is called the Huygens principle. Okay, Huygens principle states that every point on a given spherical wavefront can be considered as a secondary point source of electromagnetic waves from which other secondary waves or wavelets are radiated outward. Okay, so suppose this one is your light source, and that is what your primary wavefront, and wavefront is what a locus of points where each point is vibrating in the same phase. Okay, so from each point, okay, you can generate the secondary wavelets or the secondary wave. Okay, that principle is told by what? As the scientist Huygens. Okay, that's why the name is Huygens principle. Next we'll go for the other properties of radio wave, that is called what? Your interference. Already I've told you interference is what? Whenever two or more waves are superimposing with each other, then interference phenomenon occurs. So interference is what? Is the linear superposition of electromagnetic waves, and it occurs whenever two or more waves simultaneously occupy the same point in space. Okay, so see here, two electric vectors are there, E1 and E2, and they are making a phase angle theta. Okay, then the total vector, that is E value can be calculated by taking the phasor addition of E1 and E2. So here E1 into E2 are what? The voltage vectors, and the E represents what? The total voltage, and that is calculated by the phasor addition of these two component or the constituent vectors. Okay, and depending upon the angle theta, the phasor addition or subtraction may occur. Okay. Then another thing is that radio wave interference occurs when two or more electromagnetic waves combine in such a way that the system performance is degraded. And in from physics, you know that your interference nature may be constructive or destructive in nature. In data communication, your radio wave interference is destructive in nature. That means your system performance is degraded by means of what? Interference. Okay. See here, here I have taken one example. Suppose this one is your light source. From that light source, one wave is traveling along the space, and another wave is coming from the that same light source, and that is supposed termed as wave B. But it is passing through the Earth's surface. That means some types of other optical phenomena like reflection or refraction occurs there. That's why it is bending. But at the point X in the space, it is meeting. Okay, that means here the interference phenomena occurs. That means both wave A and wave B are meeting at that place, and they are taking or occupying the same area in the space. Okay, thank you.